Hi, today I'd like to share with you a topic that's quite important in any software project, and that is quality assurance or QA. As we all know, software development is constantly evolving. There are always new challenges, new changes, new improvements, and sometimes older practices become outdated and disappear. So in this talk, I'll focus on one particular aspect: how quality assurance had evolved and adapted through the changes in software development over time. In today's sessions, we walk through four main parts. First, we look at the big picture, how software development practices have evolved from traditional waterfall models to Agile, and now to work DevOps. Second, we explore how the role of QA has shifted during this transition, especially how QA adapted when moving from waterfall to agile environments. Third, we continue that journey into DevOps and see how QA continues to evolve to keep up with the fast pace of continuous development and integration. And finally, we talk about AI and its impact on QA by looking at some real examples of how AI is starting to reshape the way we think about quality assurance today. In any field, whenever a problem arises, people naturally look for ways to improve, and from that effort, new solutions are born, or methods are either replaced or adjusted. That's the natural way of progress in everything around us. Software development is no exception. Every project brings its own set of problems, and the problem drive the need for change and improvement. The software industry was originally followed by the waterfall model, which was very popular from the 1970s up until the early 2000s. But over time, teams started to run into issues with waterfall: late recovery of bugs, slow feedback loops, difficulty changing requirements, and high costs when problem or misunderstanding were only catch near the end of the process. In 2001, Agile was introduced. It addressed many of these weaknesses by promoting faster feedback, more flexibility, and iterative delivery. Since then, many software companies have gradually shifted toward Agile, but Agile wasn't the final stop either. As projects and systems grew larger and more complex, Agile itself faced new challenges, especially when it came to speed, scale, and collaboration across teams. That's when DevOps started to emerge as a more holistic solution, helping to bridge the gap between development and operation and push the pace even further. Now, just to clarify, today's session will deep dive into waterfall, agile, or DevOps as development models. Instead, I want to focus on one specific aspect: how quality assurance has changed, adapted, and evolved as the development world shifted from waterfall to agile and to DevOps. So, first, let's take a close look at how the role of QA shifted as the software development process moved from waterfall to agile. Waterfall was one of the very first software development methodologies. In this model, the entire process is carried out in a strict sequence, starting with requirement analysis, then development, followed by testing, and finally deployment. However, projects that follow the waterfall model often face some serious challenge. Bugs were usually discovered late in the process. Feedback from testers and clients came too late, often when the most of the work was already done, and as a result, fixing issues or making changes become very expensive and time consuming. To address these problems, the Agile methodology was introduced. Agile breaks the development process into short, repeatable cycles called iteration. Each iteration includes all the essential activities: analyzing requirements, coding, testing, and even deployment, all happening in a much shorter time frame. Thanks to this approach, feedback comes earlier, problems are identified and solved faster. Even Agile breaks a project into smaller iterations. In reality, many teams still operate each iteration like a mini waterfall. Here's how it often plays out. Business analysts write the user stories, then dev and QA work separately. Developers start building the features based on their own understanding. Meanwhile, QA write test case based on their interpretation. Once development is done, only then does testing begin. At this point, if there was any misunderstanding or missing detail in the requirement, conflicts arise. The team has to go back, rediscuss the requirement, adjust the code, update the test case, and all of that takes extra time and increased costs. To solve this, many teams apply the concept of shift left testing. That means BA, Dev, and QA get all involved earlier, right from the requirement analysis phase. The team clarifies the requirement together upfront, and collaboration is strengthened before any coding or testing even begins. With this approach, QA is no longer just the person who finds bugs after the code is written. Now QA actively analyzes risk, identifies potential issues in the requirements, and helps the whole team build a shared understanding of quality from the very beginning. Techniques like behavior-driven development also support this simple mindset, making it easier to write tests that align with business expectations and reduce the misunderstandings early on. In the previous slide, we talked about collaboration as a key principle in Agile. In this slide, let's take a close look at how collaboration changes when moving from waterfall to Agile. In the waterfall model, the development process is linear, starting from requirements to development to testing. Teams are often organized in separate functional groups. The BI team works on requirements, the development team builds the product, and the testing team checks for defects. Each team mainly works based on the output of the previous team, usually through documentation. For example, the BA writes a very detailed software requirements specification (SRS) document, which is handed over to dev. Then, once they finish coding, it's handed over to QA for testing. These teams often work independently, and most communication happens through documents. There are some level of collaboration, but it's often limited and indirect. Because of this, different people might interpret the same requirement differently, leading to misunderstandings, conflicts, and bugs later in the process. In contrast, when moving to Agile, teams are cross-functional, meaning a single team includes BA, Dev, and QA all working together. Team members collaborate directly and continuously throughout each sprint. Face-to-face or real-time communication is prioritized over heavy documentation. Documentation still exists, but it's usually lightweight and just enough to move forward. For example, instead of a long SRS document, Agile teams use short user stories, and details are clarified through ongoing discussions like backlog grooming or sprint planning. Since Agile encourages responding to change, overly detailed documents can quickly become outdated. And collaboration doesn't stop within the team, it also changes how we work with customers. In waterfall, requirements are locked down in a contract and rarely change. In Agile, customer collaboration is more important than contract negotiation. After each iteration, the team delivers a working product, gather feedback early, and use that input to stay on track and avoid building the wrong thing. Now, let's move on to another important shift, the role of automation testing. In the waterfall model, testing was mostly done manually. Automation was rarely used, mainly because testing happened at the end of the development cycle, and there was much need for repeating tests. But things changed significantly when teams adopted Agile. In Agile, every iteration delivers a working piece of software, something that could potentially be released. That means we need to test the same core features over and over again, also known as regression testing. And in large projects, the amount of regression grows rapidly. Manual testing alone simply can't keep up. That's why automation has become essential, not just to save time, but to ensure both speed and quality in agile development. Here, I've included a chart showing the rising demands for automation roles in companies. This trend clearly shows that automation isn't just a theoretical concept, it's something that real world projects are actively looking for. So, in short, automation is no longer optional. It has become a must have to maintain quality in modern agile teams. With the growing demand for automation, a natural question comes up: is manual testing still necessary? And the answer is yes, but it's evolving. It's true that traditional manual test execution based on test case is becoming less common, but manual testing that hasn't disappeared. Instead, it has shifted focus to areas where automation simply can't replace human thinking. Let's look at three key areas where manual testing still plays a critical role. Risk-based testing. In large systems, automation can't possibly cover every regression scenario. Testing everything is often impossible due to limited resource, time, or system complexity. That's where testers add real value by using their experience to identify high-risk areas and focus testing efforts where it matters the most. Automation can't make that kind of judgment call. Exploratory testing. Automation only tests what is have been told to test, predefined and repeatable scenario. But to uncover new bugs, hidden issues, or edge cases, you need human creativity, curiosity, and critical thinking. Exploratory testing is especially helpful when you are testing new features that haven't been automated yet. You are exploring a new system or unfamiliar domain, or you want to simulate real-world unpredictable user behavior. UI UX usability testing. User experience is hard to automate. Things like how intuitive a feature feels, whether a layout is confusing, how real users interact with the interface. These things only humans can evaluate. So, in summary, manual testing is not going away, it's transforming, focused on areas where human insight truly matters. Instead of thinking of manual with automation as a competition, we should view them as complementary parts of an effective QA strategy. Both are necessary, and when used together wisely, they make the product better. Besides changes in process and tools, there are there's more fundamental shift that happen when we move from waterfall to agile. That's the mindset, especially how we see the role of QA. Let's look at four key changes in thinking. In traditional model, QA was often seen as the person who finds bugs after development is done, but in Agile, QA is involved from beginning, joining discussions with BA and Dev to clarify requirements, share insights on domain knowledge, edge case and risks, raise awareness about quality early on. So now, a good QA isn't someone who finds the most bugs, but someone who helps the team write the code with fewer bugs to begin with. In the old mindset, QA was often seen as the one person accountable for quality. I remember a project where after testing, the QA lead proudly sent an email saying, QA approves this release, but when bugs show up in production, everyone turns to QA. Why didn't you catch that? The real issue was BA didn't know what Dev implemented. Dev didn't know what QA tested because each group worked in isolation. In Agile, we take whole team approach to quality. Cross-functional teams with BA, Dev, and QA work closely together. QA now contributes not just through testing, but by helping the entire team think about quality from start. QA job is not to say the software is ready to release. Instead, QA provides clear information about quality such as what has been tested, what known issues exist, what remaining risks we should be aware of. The release decision is a team decision, not just QA's. Everyone sees quality from a different perspective. To the BA, quality means meeting user needs. To the dev, it means clean code and strong unit tests. To the QA, it means bug-free functionality that meets the requirements. That's why the final decision must come from a shared understanding, not just one role. In Waterfall, QA aims for zero bugs before release, a perfect product. But in Agile, a 100% bug-free release is rarely possible, especially with fast, frequent releases. So we need to balance manufacturers, speed to market, customer needs. Some things sometimes good enough equals enough. Bug severity and priority, risks and impact of known issues. A great QA doesn't aim to ship perfection, but to ensure the team has enough information to make the smart trade-offs so that we can ship the right software at the right time with the right level of risk. Another major mindset shift for QA in Agile is moving from reactive to proactive. In the past, QA often waited until the software was released before starting to test, waited for the full finalized requirements before writing test case, waited for others to push information their way. This approach means QA was always one step behind, and if there was a misunderstanding in the requirements, it was usually discovered too late, which made fixing the issue much more expensive and time-consuming. In Agile, QA now takes the initiative to pull the information they need, proactively investigate the requirement, identifying unclear areas, actively discuss with BA dev to clarify things early, asking touch questions, analyzing risks before development even begins. This shift in behavior helps reduce misunderstandings, avoid late-stage conflict, catch potential bugs sooner, and overall improve quality while lowering costs. Modern QA pulls insights from multiple sources, including carefully reading and analyzing user stories, direct communication with stakeholders, self-learning about the business domain, and observing production behavior and user feedback. For example, some companies have customer portals where users report issues. That's a goldmine of insight, helping QA understand which areas are bug-prone, which features are frequently used, and where to focus their attention and effort. This is where shift right testing comes in. Earlier, we talked about shift left, QA getting involved early from requirement phase. But in shift right means QA also looks beyond the test phase, continuing to observe the quality in production. By monitoring real-world usage, QA gains valuable feedback about risk area, common pain points, what actually matters the most to users. So, in summary, modern QA doesn't wait to be told what to do. They seek out knowledge, understand the system, analyze risks, and contribute to quality from both ends. before code is written and even after it is released. This is what makes QA truly valuable in an agile environment. Even though Agile has so many problems that existed in waterfall, in real-world practice, Agile teams still face new challenges. One common issue is that testing often gets pushed to the end of the sprint, even if the team collaborates early during requirement analysis. In reality, the workflow often becomes sequential again, like a mini waterfall inside a sprint. Here's what typically happens. Developers tend to finish code late in the sprint. As a result, testers don't have enough time to do proper testing. Many tickets end up spilling over to the next sprint because QA simply couldn't finish in time. This is not only cause delays, but also puts a lot of pressure on QA at the end of every sprint, and it creates a false sense of being agile, when in fact the team is still working in silos. Agile introduced a great improvement. It allows us to deliver working software at the end of every iteration. Each iteration produces a piece of software that's been verified and tested and is working well in the local or test environment. Once development and QA are done, the build is handed over to the operation team to deploy it to production. But here's the problem. Even when everything works fine in dev or test environments, issues often appear only after going live in production. These issues may include infrastructure-related problems, configuration mismatch, or other operational challenges that were impossible to simulate during testing. And here's where the gap shows. The gap between the dev team and the ops team makes handling the production issue much harder. In many cases, the dev team no longer owns the production environment. When something goes wrong in production, ops needs devs help to debug or fix it. But because the two teams are separated, the process isn't clear, defined, it becomes slow, inefficient, and frustrating. This hand-off creates delays, increased downtime, and makes the team feel like they are done when their part is over, even though the real user experience is just beginning. In software industry, time to market is a key factor that drives competitive advantage. Companies are constantly looking for ways to shorten the time between idea and delivery, bringing the new products or features to market as quick as possible. In my company, previously our release cycle used to take around 2 to 3 months per release. For major release with big changes, the timeline could even stretch to 6 months. Recently, the company established a dedicated team focused on optimizing the release process. As a result, we've already seen improvements. The release cycle has shortened to around 1 to 2 months. We aim to push it even further, release every 2 to 3 weeks instead of every 1 to 2 months. In an ideal scenario, we want to reach a point where every commit could be safely deployed to production as long as it passes all quality gates and testing steps. But with the existing limitations in our release process, this goal, releasing every few weeks or deploying every commit, is not yet feasible. There are still gaps and bottlenecks we need to address before reaching that level of agility and confidence in our delivery pipeline. And that's why, as a response to all these challenge, our company is now moving toward a DevOps approach. The main purpose is to bridge the gap between teams that develop the product and the teams that deploy and operate it. DevOps is not just a set of tools or processes. is a culture shift, a way to bringing development and operation closer together. It uses key practice and technologies like continuous integration, continuous delivery, monitoring and observability, and infrastructure as code. This helps streamline the workflow from development on the way to production. Building DevOps is not just about creating automated pipeline or coding infrastructure. It's also about building a shared mindset where everyone shares responsibility from developers to QA, from DevOps engineer to product owners. Everyone is accountable for the quality, stability, and operational success of the product. And that's why implementing DevOps requires more than just technical actions. It takes company-wide alignment, not only building pipelines, but also restructuring teams, redefining ownership, and changing how we work together. In today's session, I won't cover every aspect of DevOps. Instead, I focus on one key area, the role of quality assurance in a DevOps environment. Let's take a moment to observe some of the limitations of Agile and how DevOps can have filled the missing elements. Agile gives us iterations, but inside each iteration, we often still work sequentially. Even in Agile teams, it's common to see this pattern. That finishes the code, then QA starts testing. Feedback comes only near the end of the sprint. So even feedback is faster than in waterfall, it's still too slow if we want to release frequently, or even after every sprint. This is where continuous integration comes in. With CI pipeline, the feedback loop starts as soon as dev open a pull request. We can immediately run code quality checks, unit tests, and apply the right quality gates depending on the type of change or application. We no longer have to wait for deployment to a test environment or wait for a QA to manually validate things. CIs have shipped testing to the left. At our company, we already have CI pipelines in place, but right now, most tests in CI are limited to code quality checks and unit tests. To really ensure its commit is production ready, we need to gradually expand CI coverage to include integration tests, contract tests, performance tests, and functional testing. Appropriately depends on the context. This way, every build we produce becomes a well-tested artifact ready for deployment. CI also solves something more subtle, the human psychology problem. In a sequential flow, developers often feel like, I've finished coding, now it's QA job. This leads to a natural resistance to change. If a bug or misunderstanding is found late, people may get defensive instead of being open to collaboration. Also, once they finish coding, they switch contact to another ticket. If a bug comes back during testing, they need to shift their focus again, which is inefficient. CI helps avoid almost all of this. It keeps them in the feedback loop, helps them fix issues faster, while the context is still fresh, and promotes a shared mindset around quality. But CI alone is not enough. After dev and QA produce a high-quality build, we still need to deploy it to production. If this deployment along with infrastructure and configuration is still manual, it becomes slow, error-prone, and a bottleneck even when the software itself is ready. That is where deployment side of DevOps comes in. Using deployment pipelines, automating infrastructure as code, automating configuration as code. This helps us deploy faster and more reliably, ensuring that the releases are not held back by manual steps. Finally, let's talk about collaboration. Agile did a great job of improving collaboration within the development team between PO, Dev, and QA. But the collaboration between Dev's team and Ops teams often remains limited. This is where DevOps bring real value. It encourages shared responsibility and closer collaboration between development and operation, not just inside the development team. So, DevOps doesn't replace Agile, it complements Agile. It fills the missing elements and takes us one step closer to truly continuous delivery. Now that we've seen how DevOps fills in some of the key gaps in Agile, especially in terms of automation, collaboration, and deployment, let's shift our focus to quality assurance. How does QA evolve when a software development process moves into DevOps? In DevOps, one of the biggest questions for QA is how can we move fast and still maintain quality? And the answer lies in one core practice: continuous testing. Instead of waiting for QA team to manually test after the fact, we need to integrate testing directly into the pipelines, the same pipelines used for building, releasing, deploying software. This means every time a developer pushes a commit, that change is immediately tested and the team gets real-time feedback on its quality. No more waiting days for a test cycle. No more bottlenecks at the end of the sprint. Just fast, automated, continuous validation. This shift changes everything. In Agile, test automation was important, but in DevOps, it became critical because without automation and continuous testing, DevOps simply doesn't work. You can't release every few hours or every day if you're still relying on slow manual test cycles. So for QA, the mission becomes clear. Help the team move fast but safely by making testing a built-in part of the delivery process, not a separate phase. To make continuous testing truly work, the role of QA also needs to evolve. Let's take a look at how this role has changed over time. In Waterfall, QA focused on finding bugs usually after development was done. In Agile, QA shift left to prevent bugs by getting involved early in requirement discussions. But in DevOps, QA goes even further. QA now is expected to build quality into the system itself. This means QA is no longer just a tester. QA becomes a quality architect. Key responsibilities include designing a clear strategy for testing in pipelines, defining multiple layer quality gates, unit tests, integration tests, performance tests, E2E tests, etc. Deciding where each type of test belongs in the pipeline, and set up KPIs to measure the test health, stability, and coverage. But it doesn't stop at just designing the strategy once and leaving it. QA must also monitor the test pipeline regularly, identify flaky tests, false positives, and bottlenecks, continuously tune and improve the test strategy, adapt the approach as the systems grow and requirements change. So, in DevOps, QA takes on a new mission to create a system where quality is continuously validated, automatically, reliably, and at every stage of delivery. QA becomes the enabler of safe speed, helping the entire team deliver faster with confidence. Now, some people may think that the idea of every commit being ready for production is a bit unrealistic, but in fact, this level of DevOps maturity is already happening, and is being done successfully by some of the biggest tech companies in the world. Take Netflix, Meta, or Amazon for example. These companies perform dozens, even hundreds of deployments to production every single day. Each small change goes through automated pipelines, is tested, verified, and monitored continuously, and deployed to production safely, confidently, without human bottlenecks. This proves one important thing. It's not a fantasy, it's a reality, and it's the direction our entire industry is moving forward. It reflects a broader shift in tech toward automation, toward real-time feedback, and toward continuous improvement. all enabled by DevOps. So if we are not there yet, these examples show us that it's possible, and more importantly, it's worth aiming for. To truly keep up with the direction DevOps is heading, QA needs to evolve, both in skill set and in mindset. Let's start with the skills. First and most obviously, automation is a must. It's no longer a nice to have. If we want to move fast without breaking things, we need automation at every level. Second, we don't all need to become infrastructure engineers, but QA should have basic understanding of infrastructure and test environments. Because no matter how good your test scripts are, if the environment is unstable or misconfigured, the results are meaningless. So being able to validate environments, detect config issues, and understand how infrastructure is provisioned, it's become critical skill. CI/CD pipelines are the core of DevOps. QA should know what tests run where, how test failure affect deployment, and how to troubleshoot and improve pipeline feedback loops. This knowledge helps QA contribute earlier and more effectively. And finally, maybe most importantly, an experimentation mindset. Automation is great at repeating known tasks, but what it can't do is monitor patterns, spot trends, ask what ifs, or improve broken processes. That is where human insight comes in. So, modern QA should treat processes and tools like experiments. Don't just follow the flow. Observe, question, adjust, improve. That's what makes QA not just a checker, but truly quality and enabler in DevOps. As QA continues to evolve, it would be a huge miss not to talk about the role of AI. We all see how AI is transforming every aspect of our lives, and software development is one of the areas most affected. Code generation is getting faster. Thanks to AI, developers now can produce code in minutes that may take hours or even days before. This sounds great, but it comes with a shift. The bottleneck is no longer in development, it's moving to work testing. Many teams are now struggling with growing backlog of tickets waited to be tested. On top of that, AI-generated code often comes with uncertainty and risk. If developers don't truly understand what AI has written, QA needs to be even more alert, more precise, and more critical. So, ironically, in the age of AI, QA becomes even more important. But we also hear another story. Companies are cutting headcount and many QA roles are being eliminated. So what's really going on? Here's my personal take. Yes, manual testing beyond repetitive test case is being phased out. But the demand for QA who understand AI and who can handle AI generated risks is only going to increase. In short, AI will not eliminate QA, but it will raise the bar for QA needs to do. QA in the future needs to be more strategic, more technical, and more analytical than ever before. Honestly, I'm still pretty new to exploring how AI can support QA, but even in the short term, I can clearly feel the impact. It's helping me work faster and more effectively. Let me share a few examples. The first area is communication. Whether it's writing emails, reviewing pull requests, or discuss technical issues, AI has been a huge help. My English isn't always strong enough to fully express what I mean, especially when discussing complex topics. But with AI, I can draft a clear and structured version of my message that makes me a lot more confident and efficient when working with teammates across the globe. The second thing is documentation. Even though AI encourages lightweight documentation, we still need clarity for test case, test results, bug reports, etc. Using AI to help write or polish those documents makes them more structured, more readable, and again, it helps me feel more confident sharing them with the team. Next is test case generation. Sometimes I feel when I feed a user story or requirement into AI, it suggests edge case that I didn't even think of. Of course, just like AI generated code, these test cases are just suggestions, not replacements, but they give me a solid base to work from and help me design better coverage faster. Before using AI, though, we all need to be careful with security and company policy. Please make sure you don't share sensitive data and try to use AI tools that are approved by the company. AI also helps me a lot with test automation, writing and debug scripts, understanding errors and root cause, even learning new tools and frameworks. There are also more advanced tools out there, like AI-powered auto-healing when UI changes, but many of those require paid license or enterprise tool. Still, it shows that potential is huge. To me, AI is not replacing QA. It's like a very powerful assistant. If we learn how to use it well, it can make us faster, sharper, and more confident in our work. I hope this gives you some idea and inspiration to explore what AI can do for your journey of QA too. At the end of the talk, no matter how much software development has changed from the past through the present and into future, quality has always been and will always be essential. The way we ensure quality may evolve from waterfall to agile to DevOps to AI-powered processes, but the need for quality never disappears. What does change is how we approach it, and to keep up, we need something even more important than tools or frameworks. We need a growth mindset. Growth mindset, the willingness to learn and adapt, is what will help us go further, grow stronger, and stay ready for the change of today and the unknown of tomorrow. Thank you so much for listening.